Hi, and welcome to Day 4. Now, this starts the second half of our Chemistry and Geology section, in which we're going to use metamorphic minerals and rocks that have been shaped into beads, and eventually we're going to make a necklace out of these beads. So, first, let's take a look at your beads. So, starting with the bag full of light-colored rocks, which well, I'll cut to a video here of those in a minute so that you can see exactly what they are. But these represent the feldspar, so they are the original rocks. These are the rocks that you started with that are not necessarily metamorphic minerals and rocks. Feldspar can be, but it's also formed in a lot of different environments. So it could go into any of the three types of rocks: igneous, sedimentary, or metamorphic. And so these are not considered metamorphic minerals because they don't only form in metamorphic environments. So let's go ahead and take a look at these rocks now.
Hi, and welcome to the bead section of our Chemistry and Geology session. We're looking at metamorphic rocks, and in this session we're going to actually use metamorphic rocks to bead a necklace. Now, when you take out your metamorphic chemistry geology kit, you'll have two bags of beads. One of them is going to have maybe a little bit smaller beads overall, but it's going to have much more of a dark brown and even dark red look to it, along with some really shiny white, really small chips. Those are the metamorphic minerals themselves, and so we're going to set those aside and talk about those in another video. This bag will have a lot of these gray round balls in them, and also the triangular shaped, and they're going to be quite large, and a long rectangular pink to brown bead in it. This represents the feldspars, and this is what we're going to look at during this video. So we're going to open them out and start separating according to what they are. The first ones I'll show you are these gray round beads, and it may help when you take out your beads to take them out on a towel like we're doing, because otherwise they roll all over the place. So that may help a little bit. So sort out your beads. You should have about 12 beads in there. Let's see if I've got it. 2, 4, 6, 8, 10, 12, 14, 15. We have 15 beads. Your actual number of beads may vary. But these are, they shouldn't have any variation in them. They're pretty blah, actually. They're beads that are just kind of a neutral, and they're just going to add to your overall color scheme. But these are feldspars, and this is called plagioclase feldspar. And they are not a metamorphic mineral in the sense that they don't only form under metamorphic conditions, but they can be found in metamorphic rock. However, because they can be found in igneous and sedimentary as well, we call these just original rock, minerals, or a mineral that shows up in all of them. They're kind of universal. Next, we're going to look at these grayish beads. And these are the triangular shaped beads. Looks like we've got 11 in this package. Your package may vary just a little bit from this. But these are a grayish. You can see that they're a darker color than the round beads. They're triangular shaped. They're pretty large. And they have, when you look really closely, they have a really dark mineral in them, like a black mineral. And that could be plagioclase or... I'm sorry, not plagioclase. It could be pyroxene or amphibole. Those are darker minerals, and this could have formed from magma that had a higher temperature. Now, the next ones we're going to look at are these rectangular beads, and they can be, you might find pink, you might find swirls of pink and gray. Looks like we have about an uneven number here as well. 2, 4, 6, 8, 9. So you may have more or less than that. These are what's called potassium feldspar. And so these are going to be a little bit, potassium gives it usually kind of a pink color. And they also may be a little bit gneissic. They may be actually the rock called granite, which is an igneous rock, and they might have a little bit of metamorphism in them, and they might have swirls and almost be like a gneiss in them. But they represent the mineral K-spar or potassium feldspar, and that's why they're kind of pink to brown. And then finally, you will have these beads, and they're going to be really light. It looks like I've got 6 of them here. They're going to be really light in color, and there's going to be 2 different possibilities. If they are pretty translucent and they have a little bit of a bluish sheen to them, they're going to be moonstone, the gemstone variety moonstone. That is also a plagioclase feldspar. So overall, all 4 of these will be feldspar. If you don't see any blue material, I did include in some people's bags quartz, just regular old quartz. And so if you can't find that bluish sheen, you have quartz. Now all together in these original rocks, I put these out here because these rocks contain potassium, aluminum, silicon, and oxygen. And the aluminum, silicon, and oxygen is going to recombine and form some of these metamorphic minerals that we'll talk about later under metamorphic conditions. So when you add pressure, temperature, and some chemically active fluids, these are going to, sometimes the edges of them or altogether all of them will break down and form new minerals. And so we'll look at those metamorphic minerals in the next video.
Okay, and so you've looked at the original rocks or the feldspars. Now what we're going to do is we're going to make metamorphic rocks. And to do that, you need to have pressure, temperature, and chemically active fluids. And that will help the feldspars kind of rearrange their elements into new minerals, metamorphic minerals. Now note the website at the bottom. If you want to go back and look at this later, you can. We will look at it upcoming. We won't look at it right now, but we will during this session. Now let's start with relatively low pressures and temperatures. That's going to create garnet. Okay, so garnet is a kind of a complex mineral, and it will kind of rearrange and bring in a bunch of different materials that have kind of come in with the chemically active fluids to create a new mineral. Let's go ahead, called garnet. It also creates relatively low pressures and temperature. Will create andalusite or starlight. And so we'll look at that as well. So let me bring up these websites. The first one is garnet. So you can take a look at these later as well if you want to stop the video and see what the website is. But garnet, a lot of times people think garnet only comes in red. That's actually not true. It comes in all different colors, and these are all examples of garnets. And so as you can see on the side, they form from metamorphic igneous and sedimentary rocks. And note all those different colors, especially from mint green all the way through pale pink and into purple, orange, and then into the red that we know so well. Now the next website is andalusite. That is another mineral that is formed from relatively lower pressures and temperatures. Still high enough to be called metamorphic rock, but this is andalusite. There it is on the side. It's sort of a rock that's brownish with some gold sheen to it. And then here is the little chart that shows you across the bottom, this is temperature getting higher and higher, and this is pressure getting higher and higher going up. And so andalusite, you can see, is kind of low because it's kind of more on this side of the temperature, and it's more down towards the bottom of the pressure side. So even though it's a metamorphic rock, it is down into the lower temperature and pressures that it's going to form in. And its mineral composition is aluminum, silicon, and oxygen. So Al2SiO5. And that is the same with andalusite, sillimanite, and kyanite. And we'll see that in more detail in a little bit here. Now, going back to our slide, here's some examples of garnet. These look kind of similar to what you saw on the website there, but you can see in the middle the very traditional January birthstone of garnet, deep red. And then on the right side, you can see that it's kind of pink and it's more of the raw form. And then on the left side, it's a almost yellowish green color garnet. And so they can appear in every color besides just red. And here's some examples of andalusite. These are gem quality, and so you're not going to quite have gem quality andalusite beads in your kit, but you will have, the ones that you have will look somewhat like this. They're kind of a brownish red with a lot of gold sparkle to them. So they're a fairly pretty bead, and at this point now, let's go and take a look at your beads and your metamorphic minerals and see what your beads look like.
Back again now to look at the other bag of beads that you have. Now in a previous video we looked at these beads. Those are your feldspars, and they have potassium, aluminum, silicon, and oxygen. This bag is going to be the metamorphic minerals, the minerals that form kind of solely under metamorphic conditions. So they are going to take those raw materials, potassium, aluminum, silicon, and oxygen, and recombine them in new ways to form new minerals. So let's take a look at what we have. Okay. The first two that we'll look at in this video are ones that form under lower temperatures and pressures generally. And this is going to be the really dark kind of irregular shaped beads. Those are garnet. And it's also going to be this bead, which is going to be more round, and that's andalusite. And so let me find them all for you here, and then I can kind of tell you how many you have of each. You should have 11 of each in your bag. So again, it's really a lot more helpful to put these out on a towel and even start to bead and design your necklace on a towel, because that prevents the beads from flying all over the place. Okay. Let's see. Let's check. 2, 4, 6, 8, 10, 11. 2, 4, 6, 8, 10. Oh dear. Okay, you want to separate out the beads that are really round. That's going to be another metamorphic rock that we'll cover in a future video. And you want to separate those out from ones that are they're round, but they're a little bit more irregular. Okay, here we go. 2, 4, 6, 8, 10, 11. You may want to take some time to really think and study your beads a while and make sure you've got the right ones in the right areas. It's a little bit of metamorphic mineral identification that you have to do to make sure you've got the right beads in the right area. So let's talk about garnet first. Garnet forms in a variety of metamorphic rocks, and so it's generally formed in you find it in like slate or schist, and you can find actually big pieces of the mineral garnet, and sometimes this can be a gemstone. If your birthday is in January, it's the birthstone for January. These are going to have a red look. They're going to be somewhat translucent, and you might, if you hold it up to the light, you might see red through it. So just a little bit translucent, not like, your slime or anything like that, but they'll have a little bit of just a glimmer of where you go, yeah, if that was in a better shape, it could maybe become a gemstone. They're going to have irregular shapes, and they're going to be the largest beads in your bunch. Now, the next mineral that I'll talk about that forms under lower pressures and lower temperatures, but high enough to be called metamorphic, is andalusite. And this is going to be they're going to have a lot more sparkle to them, and they're going to be kind of a brownish shape. They're almost going to look like they have golden sparkles within them. They're going to be somewhat like the garnet in that they're not going to be super translucent, but if you hold them up to the light, they'll have a little bit of translucency. And they're going to be kind of a flattened, round shape. So they're not going to be completely round like these other ones in your bag. They're going to be more of a flat round. Now, andalusite is aluminum, silicon, and oxygen. So this takes the raw materials given to it from the feldspars and recombines it into a new mineral that's formed under lower but still pretty high pressures and temperatures in metamorphism. And andalusite can sometimes be faceted into a gemstone. As you can see, it's kind of a pretty brownish gold color. And so that is andalusite, and that is the first two sets of lower pressure, lower temperature metamorphic rocks or minerals that you've got in your bag. Okay.
Okay, well, let's take a look at what happens when you add higher pressure to your metamorphic suite. What you create is a mineral called kyanite. Kyanite is aluminum, silicon, and oxygen. So if that chemical formula looks like something you've seen before, you have seen it. It is the exact same chemical makeup as andalusite, but it's going to look different because of the different pressure and temperature that kyanite forms at. So let's go ahead and take a look at the website for kyanite. There was andalusite. Now we're moving on to kyanite. Now this is the same, it's called a polymorph because it's the same Al2SiO5. And these three minerals have a chemical composition that's the same, and it's kyanite, andalusite, and sillimanite. And so we're going to look at sillimanite here in a little bit. So a spoiler alert is you do have all three beads of these in your pack. So these form in metamorphic rocks. It's the high pressure variety. And here's some gemstones. If you look at what kyanite looks like when it's really clear and does not have any impurities or anything like that, it's quite attractive mineral. And it's used, often it's shaped like this as a smooth top. Not a sparkly gemstone, but one with a smooth top, and it's set into jewelry as well. So let's look at some examples of kyanite. Here's an example of a really nice mineral with good color in it, and that has what's called good crystal form, in that it kind of forms in these long bladed type of crystals. And so there's sort of, when you find kyanite as a specimen, you often find it like this, as a bladed specimen. And here's another example where you can still see those long rectangular shapes on both pictures, on both the big one on the left and the smaller one on the right. But they're not always that gemstone-like. And so you can find kyanite even in Wyoming, up in the Laramie Range, and I have seen an example that looks kind of like the one on the left, except that the blue parts, the kyanite, were not quite as blue as they are in that photo. So they weren't gem quality, they were just regular kyanite. And so let's go ahead and look at your beads. Now your beads are going to also have ruby in them. So we kind of got two metamorphic minerals for the price of one in one bead. So your kyanite will have a little bit of red in it or pink, and that's going to be the ruby. So let's go ahead and take a look.
Hi. Now we're going to look at slightly higher pressures and temperatures in the minerals that form there. This is going to be kyanite, and we're also going to include sapphire in here. So the kyanite are going to be the brownish, grayish beads that are truly round. And so I would put them right next to the andalusite so that you can see the difference a little bit easier. You're also going to have 9 of these, not 11 like the andalusite. You're going to have 9. Kyanite is formed under higher pressures and temperatures than andalusite. It is what's known as a polymorph, though, of andalusite because it has exactly the same chemical formula. It has aluminum, silicon, oxygen in exactly the same proportions. It's just that it forms a completely different mineral under these higher pressures and temperatures. The other thing that you might notice about the kyanite is that, first of all, it's pretty opaque. It's not translucent at all. And secondly, you might see some pink in it. That pink is ruby. Ruby is another mineral that forms under metamorphic conditions. And ruby is the gemstone for July birthdays. So if you have a birthday in July, that's your birthstone. And these are not gem grade rubies. As you can tell, you can barely see a pink color, but nevertheless, that's what those are. Now, the final thing, and these are the littlest beads in your bunch, are going to be 7 blue sparkly beads. Those are sapphires. Sapphire is a metamorphic mineral. Sapphire is aluminum oxide, and it is a very simple mineral, aluminum and oxide. And interestingly, it is the exact same mineral composition as ruby. Sapphire and ruby are gemstone names for the mineral corundum. And probably, especially in your kyanite, this is corundum, the mineral, not very much the gemstone ruby. This is a little bit more of a gemmy type of corundum, so I would go ahead and call this sapphire. And this is the birthstone for September. So if you have a September birthday, this is your birthstone, sapphire, and you should have 7 of these little beauties. So this is your kind of suite of getting to be higher pressure and temperature metamorphic minerals.
Okay, and now the moment that you've been waiting for, the highest pressure and temperature and the highest grade metamorphic rocks. These high pressures and temperatures, they're still low enough that the rock has to stay at least partially solid. So they can't go any higher than this or else the rock will melt completely and there'll be an igneous rock and not a metamorphic rock. But the mineral that forms at these high pressures and temperatures is sillimanite. And the way to remember that is I always think of it as kind of a silly rock, sillimanite. It also has the same composition, so this is the third rock in the suite. It's Al2Si05, and so it's taken all those raw materials from the feldspar and rearranged them and made a new mineral. And this looks different as well because of the high pressure and temperature that forms sillimanite. So let's take a look at some of those websites. Here was kyanite. Now we're going to increase the pressure and temperature, and we're moving into sillimanite. So there it is. You can see it's kind of a whiter shade. So it's a lot of the specimens are much lighter gray than the ones that the kyanite and the andalusite. If we go to the other site, we can kind of see the different metamorphic reactions that happen to go through all these stages. And so andalusite, here is the kind of the chart again with temperature starting at 200 degrees Celsius. So when we say low temperature, it's not all that low. 200 degrees Celsius going all the way up to 700 degrees Celsius along the bottom. And at the top, the pressure is going from 0, like sea level, all the way up to 8 kilobars of pressure. So high pressure there. There's the Andalusite. There's the kyanite, still kind of on the lower temperature, but definitely higher pressure side. And here is sillimanite. That's in very high temperatures, and so almost high enough that it could melt that rock, but it doesn't, because remember, if it did, it would become an igneous rock. So let's take a look at some of these examples then. Here is a sillimanite rock, which is not quite as white as those minerals, the specimens that we saw on the website. But that is an example again. You can see that it kind of looks like kyanite and it kind of looks like andalusite because after all they are the same chemical composition. They just look different though because they have all formed at different pressures and temperatures. So do your beads look like this? Let's go ahead and find out.
Okay, we're up to the very last mineral that you have in that bag. You should have about 18 of these, and they're very irregular. They're white, and they almost look like little chips of, well, they are chips of the mineral, but they could look like little chips of teeth or bones or something like that. They're not. They're the mineral sillimanite. And sillimanite forms at the highest pressures and temperatures. So it actually, and these are mineralogically, they have this exact same chemistry as kyanite and andalusite. So as you increase in pressures and temperatures, when you metamorphose minerals, you go from andalusite to kyanite to sillimanite. These have been coated with the material, and that's why they're sparkly. They're also really crumbly, I've noticed. So don't worry about it too much if they crumble apart in your hands. We gave you a lot more to compensate for that, but they'll just add a little bit of sparkle in your overall metamorphic assemblage. So here they all are. Here's your metamorphic minerals. You've got the lower grade metamorphism, lower pressures and temperature, garnet, andalusite, the set of 3 that are all aluminum, silica, oxygen. So andalusite increasing the temperature to kyanite, increasing the pressure to the highest pressure and temperature, sillimanite. And then you've got 2 additional metamorphic minerals, ruby and sapphire. And there you go. In the next video, we are going to discuss the actual beading. And so we're going to design the necklace, and then I'll show you how to put it all together and clasp it to make your very own necklace.